Okay, guys. So in this video, I want to go over the first section of our course, and that's Introduction to Statistics. And I'm going to be using this worksheet. It's available on Canvas. You can actually go over it by yourself. You don't have to watch the videos. I will give extra explanations here in the videos. So if you're someone who gets the information from reading very well, then you could just read the notes and you'll get all the information that you need from them. But if you're someone like me, I'm an audio person, or I need to hear the information in order to remember it and understand it and process it. Or maybe you're a visual person, then maybe this way is more suitable for you. So remember always that you can speed up the videos as well. You can put me, if you think I'm talking too slowly, you can speed it up. You could put me in the 1.5 times mode or 2 times mode, and I'll be talking really fast and really funny, but that's an option. I just wanted to let you know that's an option. Okay, so let's talk about statistics. Introduction to statistics. What is statistics? Statistics is a branch of mathematics that uses various methods to collect data, to analyze it, and present it, and also make predictions or inferences. So that's what statistic with a capital S is. Now, so here's the quote: "The study of statistics is the art of science of using data, or data, actually, statisticians say data, and to better understand the world around us." And we're going to be looking at 2 types of statistics that we will be studying. One is descriptive statistic, and this descriptive statistics entails organizing, summarizing, and presenting data. So an example of descriptive statistic: 54% of the students enrolled at Mesa are planning to transfer. So that's just a fact that we got from collecting that and analyzing that student information. And this fact is stated as is. We're not making any predictions. So this is a descriptive statistic. Inferential statistics is drawing conclusions or making predictions about a population using sample data. So here's an example. Let me move this up a little bit. So based on historical data, a student placed into Math 38, 3 levels below transfer, has only 7% chance of passing transfer level with math within 3 years. Okay, so this is again based on descriptive statistics. So first they collected and analyzed the information, but now they're trying to predict or project success rate for the transfer level math. And basically, let me go back a little bit. So once they looked at this data, they said, okay, this is not really good. Only 7% of students are passing within 3 years, math requirements within 3 years. So this is not really good. So what happened was, here when they were placed in Math 38, I need another piece of paper. So when students were placed in Math 38, then they had to basically progress to Math 46 and then 96, and only then they could be placed into Math 119. So this was the progression. So what happened when they looked at the data, what happened is that 25% of all people who finished 38 successfully basically never enrolled in 46. They got lost somewhere between these two classes. And I just want to emphasize that they did not fail. They passed the 38 and they were eligible for enrolling in 46, but they never enrolled. And then same happened after finishing 46, 25% left that course, and the 25% left after 96. So and I just basically, by the time they had to take 119, a lot of people just didn't make it there. So that is why the administrators looked at this data and they said, okay, we need to change something. Okay, so this is not a good model. And that's why they said they came up with this policy change. They said, let's, for these people who would place either in 38, 46, or 96 normally, we're going to create a new class. We're going to call it 119X. And it's going to be 119, but it's going to have a algebra support portion of it. Okay, so we're calling it 15D right now. Okay, so this is algebra support portion. This is 119, and it works really really well for stats class because stats is not very algebra heavy. So and here's a projected success rate. So this is a transfer level math, historic success, and this is a projected success. So when we make projections, then that becomes an inferential statistics. Another thing that I wanted to talk about here on this first page is the use of the word statistics in with a lowercase s. So the word statistic with a lowercase s usually refers to a characteristic of a sample. So for example, here it says, for example, the 54 figure above is a statistic. So it's referring to this phrase right now where it says 54% of the students enrolled in MESA are planning to transfer. So it tells you something about the sample that they looked at. This is a characteristic of a sample. It could be the sample size is also a statistic. So that's the statistic with a lowercase s. So now let's talk a little bit about statistical process. So why, first, we have a question that we want to figure out. So this is a research question. So what do we really want to know? And then once we figure out what we want to learn, for example, I could ask, okay, I want to know how far MESA students or college students in general in San Diego, let's make it about the entire population of students in San Diego, how far do they travel to the colleges normally? So let's say, so once we formulated the research question, then we want to figure out the study design. How are we going to obtain our information? What data will we need to answer the question? So yeah, do we have, and basically we at this level we're gonna identify our variables. What kind of data we're collecting? Are we collecting ages? Are we collecting genders? Are we collecting some other information? Basically, that will that is determined what we really want to do with this data later. Do we want to compare how far males travel versus females? Yeah. So we would have to collect genders as well. So sample, where do we get our, how do we reach our people? And who are we reaching, actually? And then what type of study it is? Is it experimental versus observational study? We're going to be talking about this a little later. So if you don't understand those terms, it's okay. And then we actually go ahead and collect our data. We're going to clean it. We're going to organize it. And then after that, we come to the phase, it says analysis. So that's where we basically analyze some statistics that we received and present. And at this point, we may also make some conclusions and projections onto the future. So that becomes the inferential. This is the inferential statistic stage. First descriptive and then inferential. And so, yeah, and basically the last concluding stage is answering the question, what did we learn about the research question? Did we answer our research question? What does our data show about what we want to know? Here's an exercise. The research question was, what are the impacts of salt on health, particularly hypertension and blood pressure? Okay, so this was the question posed. And then the study design, they decided, okay, we have access to these people who are in prison. They don't have a choice anyway. They will eat what we give them, and then they very bad. But actually, I don't know about this exercise very much. Maybe they asked for volunteers, so hopefully. And then, so they assigned prisoners to meal plans with different sodium levels, okay? And then they measured how those sodium levels affected their blood pressure. Yeah, here it says, the ethical consideration of the study design above are being debated, as noted in the article. And okay, so here we go. So they collected the data, analyzed it, and formed the conclusions. All right. Let me know if you have any questions. Post them to the discussion boards, and I will be answering them.